Good morning. Now we are going to make the revision for the science in the second term, starting with the kind of motion. We have first the oscillatory motion. The oscillatory motion, we have the oscillatory motion and the periodic motion. We have to compare between both of them, the periodic or the oscillatory motion. For the periodic motion, it is the motion of the body that is repeating. So the word repeating is very important. Repeating its motion within a certain period of time. If you are going to say like this will be the periodic motion. One of the periodic motion is the oscillatory motion. From the periodic motion, generally, the oscillatory motion, number one, and the wave motion. This is what we are going to explain it. The oscillatory motion, it is the motion of the oscillating body at the two sides of its rest position. So, number one, there is a repeating, so it is belonging to the periodic motion. Number two, around its rest position. The rest position around its meaning at the right and left or up and down to its rest position. For the examples that can make the oscillatory motion, there is the stretching string, the case of the violin here, and the tuning fork, and the seesaw. This is a kind of oscillatory motion. The most important one that will explain it clearly is the motion of the pendulum. In the motion of the pendulum, I have here the ball of the pendulum and suspending the thread. It's going to move to the right and left. Okay? The first position is the rest position. And then it's going to move right and left around its rest position. That's meaning it is a kind of oscillatory motion, and at the same time it is a periodic motion. If we want to make a graphical representation for the oscillatory motion, if the pendulum, the ball of the pendulum, first at the position A, then it moves at the position B, then returns back to the position A, then it moves to the position C, then return back to the position A. This is the graphical representation of the oscillatory motion. Motion represented by this kind of graph. Now we have four concepts which are very important for the oscillatory motion: amplitude, frequency, complete oscillation, periodic time. We have to know these four, very important. Amplitude is the maximum displacement of the oscillating body away from its rest position. Here at the point B is the maximum displacement of the oscillating body away from its rest position, or at the point C. So the maximum displacement of the oscillating body away from its rest position, will be the amplitude of the oscillatory motion. Complete oscillation, this is the oscillation of the oscillating body when it passes through a certain point two successive times at the same direction. And we have to know the calculation of the complete oscillation, which is meaning that if the body is going to make one complete oscillation, it must make four displacement. From A to B, the first displacement. From B to A, the second displacement. From A to C, the third displacement. From C to A, the fourth displacement. In this case, I can say this oscillating pendulum made four complete oscillation. Or from B to A, this is the first one. From A to C, this is the second displacement. From C to A, again, this is the third displacement. From A to B, this is the third displacement. I mean, from B to B, the body made one complete oscillation. Okay? But this is one displacement. This is the second displacement. I mean from A to A, this is a half complete oscillation because the body made two displacement only. So we have to know what is the complete oscillation and how can we calculate it. Here, how many complete oscillation in this drawing? I mean, from B to B, this is the first complete oscillation. From B to B, the second complete oscillation. From B till the end of the motion, this is the third. If I have a drawing like that, I can say this drawing includes 3 complete oscillation. Of course, each displacement is called amplitude, but it must be the maximum. The third concept is the periodic time. Periodic time is the time for the oscillating body to make one complete oscillation. You are going to calculate it by using the graph, or you can see it in the drawing. But generally, the periodic time equals time which is calculated in second over the number of complete oscillation, and we already learned how we can calculate the complete oscillation. So if you want to get mathematical calculation for the periodic time, it will be the time in second over the number of complete oscillation. Here we have a figure. This figure, you have one of 2 ways of answering the calculation of the periodic time. We can calculate how many complete oscillation till here 1, till here 2, till here 3. So I have in this drawing 3 complete oscillation, and the 9 seconds is the total time to make these complete oscillation. So the periodic time will be the 9, which is the time, over the number of complete oscillation, which is 3. It equals 3 seconds. Of course, the unit of the periodic time is the second. Here also, we can calculate it in the opposite figure, calculate the periodic time. The complete oscillation includes 4 amplitude, 4 displacement, and each displacement will take a time equals 0.5 seconds. So if you want to calculate the periodic time, you have to take 4 times 0.5. 4 is meaning 4 complete oscillation. To make one complete oscillation, 4 displacement. Each displacement, each amplitude, 0.5 seconds. And the periodic time includes 4 displacement. So it's 4 times 0.5 equals 2 seconds. The third concept is the frequency. Frequency equals the number of complete oscillation over the time per second. And there is inversely proportional between the periodic time and the frequency. The frequency equals 1 over periodic time. The periodic time equals 1 over the frequency. And the frequency times the periodic time, of course, will equal 1. If a pendulum makes 220 complete oscillation in 5 seconds, calculate the periodic time, the frequency. The periodic time over the number of complete oscillation, which is equal 5 over 20 equal 1 over 4. This is the periodic time. If I get the periodic time, I can get the frequency directly by or by the rule number of complete oscillation over the time. 20 over 5 equal 4 hertz. Don't forget the unit, the measuring unit for each concept or for each one. The unit for measuring the frequency is kilohertz, which is 10 to the power 3 hertz, or megahertz, which is equal 10 power 6 hertz, or gigahertz, which is equal 10 to the power 9. This is the first one. The second one is the wave motion. If we have a dominance here, and all of them are arranged in a certain way, if I want to push the first one, It will transfer this energy to the second one, transfer the energy to the third one, until sending the energy to the last one. So all of them will fall down. And this is the concept of the wave, or this will give me the meaning of the wave disturbance of the medium particles that propagate and transfer the energy in its propagation direction. There is a disturbance in the medium particles and transfer its energy through its propagation direction. Here, if we have the tuning fork and the lighted flame, by making the tuning fork producing sound by using it, and then the sound will travel through the first opening of the tube till reaching the flame of the candle, vibrating it right and left. If you have a sense stick, this sense stick, its vapor will not transfer from the first opening to the second opening. That's meaning in the sound transfers through the medium particles by vibrating it, not by transferring the medium particles themselves. And this is the most important meaning of the wave propagation. How the wave propagate. The wave motion, the movement resulting from the vibration of the medium particles at a certain direction in a certain moment in a specific direction. Of course, the direction of the propagation for the wave is known as the line of wave propagation. We have two kinds of waves: transverse waves and longitudinal waves. First, transverse waves and longitudinal waves, this is the first classification of the waves according to how the motion of the medium particles. I mean, the medium particles vibrate up and down or right and left. If the medium particles vibrate up and down, I have transverse waves, for example, the water wave. If the particles of the medium vibrate right and left, you might have the longitudinal waves, and this is the sound wave example. But both of them belong to the mechanical wave. Mechanical wave, another way of classification for different kind of waves, that if it has the ability to propagate and transfer its energy, needing a medium or not. The mechanical waves, I mean the transverse and longitudinal, always need medium to propagate. If there is a medium, it will propagate and travel. If there is no medium, it will not propagate or travel. The second one is the electromagnetic waves. Electromagnetic waves do not need a medium to propagate, can travel in the space with a very high speed, equals 3 times 10 to the power 8 meters per second. This is the transverse wave, and this is the longitudinal waves. The transverse waves, particles of the medium vibrate up and down. Particles of the medium vibrate right and left in the case of the longitudinal waves. So, the particles of the medium vibrate perpendicular on the wave propagation direction. Here, particles of the medium vibrate along the wave propagation direction. Here, the transverse waves consist of crest and trough. The longitudinal waves consist of compression and rarefaction. Crest is the highest point in the transverse wave with respect to the horizontal axis or plane. In the case of the longitudinal wave, compression is the point related to the longitudinal wave for the crest. Compression, the point in which the high density pressure and particles of the medium close to each other with the high density and pressure. Crest and trough, this is the lowest point, it's called trough, but the point with the lowest density and the pressure will be the rarefaction in the case of the longitudinal waves. Water waves is the example of the transverse waves. Sound wave is the example of the longitudinal waves. But what about the electromagnetic waves? The waves that do not need a medium to propagate and can travel in the space with a very high speed, which is equal 3 times 10 to the power 8 meter per second. These are the two examples about the long electromagnetic waves, which are the light waves and the radio waves. Mechanical and electromagnetic waves, according to or comparing between the velocity of both of them, always the velocity of the mechanical wave is much slower than the electromagnetic waves that propagate in the space or a vacuum with the speed 3 by 10 the power 8. If we want to calculate the wavelength of the wave, we will see what is the distance between two successive crests or two successive troughs. It will be the wavelength. Sorry. Wavelength, in the case of the longitudinal wave, the distance between two successive compressions or two successive rarefaction. It's a very important point in the case of the wave, which is in the case of transverse waves and longitudinal wave, you have to learn to calculate what is the wavelength. In the case of transverse wave, distance between two successive crests or two successive troughs. But in the case of the longitudinal waves, it is the distance between two successive compressions or two successive rarefaction. Of course, if you want to measure the amplitude, you will look exactly at the maximum point of the crest or the maximum point of the trough. If the maximum point refers to 2, that's meaning this wave, its amplitude is 2. Okay? Of course, the unit for measuring the amplitude is the meter. Don't forget that. If you want to measure the wave velocity, it will equal wave velocity equal distance over time. This is the first one of them, but we'll not use this rule anymore. Wave velocity is the distance covered by wave in 1 second, and if you want to calculate it to the number of produced waves over time per second, or the most important one, is the velocity of the wave is equal the frequency times the wavelength. This is the most important rule of them. So you have to know how to get from the drawing the value of the frequency and the value of the wave length. Here, calculate the wavelength in meter for a visible light of a frequency 6 times 10 to the power 8 megahertz and the velocity 3 times 10 to the power meter per second. Or, so the frequency, you are going to transfer the frequency from the value of megahertz to the value of hertz, 6 times 10 to the power 14. And the value of the wavelength equals the velocity over the frequency. Then you have the two values, divide them by using your calculator and then getting the end result of the problem. We have the sound waves. The sound is an external factor that affects the ear, causing the sense of hearing. The sound have 3 properties. We are going to explain it. Number 1, the sound pitch. First, we have to classify the sound waves into musical tones and notes. These are the musical tone, which is the type of the tones that uniform frequency and comfortable to be heard. Not bad for the ear to hear it. For example, violin, piano, and reed pipe, these are different musical instruments or musical tone. This is the musical tone. The second one is the noise. Noise, in this case, the frequency of the waves will appear non-uniformly and uncomfortable to be heard by the ear. For example, drilling, loudspeaker, and car horns. The properties of the sound waves. First is the sound pitch. Sound pitch is the property of the sound in which the human ear can differentiate between the rough sound and sharp sound. Sharp sound like the woman voice. harsh or rough sound like the man's voice. We can differentiate between both of them. This is the this is the frequency. This is the high pitched sound with a high frequency. Number one, the first property of the sound is the sound pitch. We said that if you want to describe the sound pitch, you will say this sound is sharp or the sound is rough. The difference between the sharp sound and rough sound, exactly like the difference between the frequency of both of them. So the frequency will be the only factor affecting on the sound pitch. If we have here rubber band between them, there is a pencil, try to make a different distance and vibrate it, hear the sound, see if it is rough or sharp in different segments between the two pencils. You will find at the end that the sound becomes more harsher if the length of the string increased, and it will be sharp if the length of the string decreased. Of course, related to the frequency of each one of them. Sound pitch, we said before, depends on the frequency. There is a directly proportional between the sound pitch and the frequency. If the frequency increased, the sound pitch increased. If the frequency decreased, the sound pitch decreased. And Savard's wheel explained that exactly. This is the wheel, it's called Savard's wheel, different types of gears with a wheel and rotating. There is a belt connected between them. Savard's wheel, this is the tool that tries to prove that the sound pitch depends on the frequency. But it's a very important rule, which is, if you want to get the frequency in the case of the Savard's wheel, it will equal the number of cycles times the number of gears teeth over the time. 1, 2, 3, 4 factors. You will have in the problem 3 of them to get the 4th one. So the kind of frequency directly proportional with the number of cycles. The frequency directly proportional with the number of gears teeth. Inversely proportional with the time. The second property of the sound is the sound intensity. This is a property of the sound in which the human ear can distinguish between the the strong sound and weak sound. Strong and weak. This is the sound intensity. Sound intensity at a certain point, or the amount of sound falls on a certain point perpendicular to the unit area of the ear. This is the intensity of the sound. The unit for measuring it is the watt per meter square. Don't forget this unit. There is 2 units, you have to know it. One of them, the sound intensity, is watt per meter square, and the intensity of noise, which is the decibel. Decibel is the unit for measuring the intensity of noise. Different factors. Distance between the source of the sound and the human ear. The first factor affecting on the sound intensity. And the sound intensity inversely proportional with the square of distance between the source of the sound and the human ear. Inversely proportional is meaning what? Increase, decrease, decrease, increase. But take care about the square. Direct inversely proportional with the square. This is why they are calling it the inverse square law. The second factor is the amplitude of the sound, which the amplitude, we had the meaning of it before, the maximum displacement. Intensity of the sound is directly proportional with the amplitude square. Thus meaning if the amplitude increased to the double, the intensity of the sound will increase 4 times because it is amplitude square. The third factor is the area of vibration. Here in the case if you are looking at the picture, this mobile, if it's ring, it is attaching to resonance box made of wood, empty from inside. You will hear intensity of sound higher than the other case if it is alone. In this case, that's meaning the intensity of the sound will be stronger if the vibrating body is touching a resonance book due to increase the resonance books, due to increasing the area of vibration. Here also, the stretching string over the violin will be over a wooden hollow box just to increase the area of vibration and increasing the intensity of the sound. The medium density, the relation between the medium density and the intensity of the sound. If the density increased, the intensity increased also, directly proportional. If you have two media, one of them higher density than the other medium, and the sound the same traveling through these two media, then you will hear the intensity of the sound will be higher in the case of the high density medium than the other one. And here also, inside this glass jar, there is a clock to make the sound, and we are using the vacuum pump to rush all the air inside it out gradually. Then you will hear the sound decrease gradually till not hearing the sound completely, because the air decreased inside this glass jar. Its density decreased till there is no air, there is no medium, the sound cannot travel. The medium density, we explained that. When direction, if the sound in the same direction of the wind, of the air, you will hear its intensity higher. If the sound will take the opposite direction of the air, the sound intensity will be low. The third property of the sound is the sound type or the sound quality. Sound quality is meaning what? The sound ear can differentiate between different sounds from different sources, even if they have the same intensity and the same pitch, due to the presence of which is called harmonic tone and fundamental tone. If you know the meaning of fundamental tone and harmonic tone, you can differentiate between both of them. Harmonic tone is several tone, while the fundamental tone is the basic tone, but both of them must be together always. We have different type of sound waves: sonic, infrasonic, ultrasonic. Sonic, when the frequency is between 20 hertz and 20 kilohertz, and this one can be heard by the human ear. The second one, infrasonic, if the frequency of the vibrating body is less than 20 hertz and can't be heard by the human ear, but can be heard by some animals, sound such as the sound of a storm preceding rainfall. Sound of storms preceding the rainfall is example of the infrasonic. The last one is and the most important one, of course, the ultrasonic. Ultrasonic, when the frequency of the vibrating body is more than 20 kilohertz. And this can be heard by can't be heard by the human ear, but can be heard by bat or dolphins and so on. Some animals can hear it. We are using the ultrasonic in different purposes: in breaking kidneys and urethral stones, diagnose the male prostate gland tumors. In industry, we can use it in sterilizing food, water and milk, because they have the ability to kill the bacteria. In military purposes, we can discover by using the ultrasonic waves the landmines. The last thing in the unit 2 is the light. The light is an external factor that affecting the ear, causing the sense of affecting the eye, causing the sense of vision. Light velocity, of course, because it belongs to the electromagnetic waves, so it is the distance covered by light in 1 second, and its value is so high, reaches to 3 times 10 to the power 8 meter per second. If you are going to make the analysis for the light by using triangular prism or by using whatever tool, you will see that it is composed of 7 colors. These 7 colors are called spectrum colors. These spectrum colors are red, orange, yellow, green, blue, indigo, violet. They will come out from the triangular prism, can be received in a white screen, and you will see that the red color here, if you are going to move in this direction, wavelength decreased and the frequency increased. Frequency increased is meaning red, low frequency, long wavelength, low energy. The violet gradually till reaching to the violet have the wavelength, shortest wavelength, but highest frequency and the highest energy. Take care about this point in the examples. Max Planck proved that in light is group of photons or quanta. These photons or quanta depends on its frequency. So he said that you can get a rule which is to get the energy of this photon energy is equal constant value, which is named Planck's constant, times the photon frequency. According to transparent, if the light can travel through the medium with a high or medium or low or doesn't pass completely, we can classify the materials according to that into transparent medium that allow the light to pass through it, such as the air, pure water, allow most of the light to pass through it. Just the word most. The second one is the translucent or semi-transparent medium that allow some of light to pass through it, such as the flint glass. Absorb part, remaining part pass. The third one is the opaque medium, doesn't allow the light to pass completely through it. Light intensity, amount of light falls perpendicular on the unit area, and if the distance increased, this intensity of the light will be decreased also, and this is called inverse square law, exactly like the sound. We have a reflection for the light and the refraction for the light. Reflection for the light is the rebounding of the light ray due to hitting a reflecting surface. Here, group of light ray fall on the reflecting surface, so they reflect in the same medium, not transfer to another medium. This is called reflection. What happened here? There is a rebounding or returning back of the light ray due to hitting a reflecting surface. And this kind of reflection exactly is called regular reflection. When the light ray falls in a smooth surface, such as the plane mirror, and they are reflected in one direction. But look at this picture. This is irregular or non-uniform reflection if they are reflected in different direction, and this is a non-uniform, and this is a rough surface, not a reflecting surface, not smooth surface. Laws of reflection, you have to know it very carefully. This is incident light ray, this is incident light ray, this is reflected ray, and then we are making the line which is perpendicular to the reflecting surface at the point of incidence. There is an angle between the incident ray and the normal, and there is an angle between the reflected ray and normal. We have two rules. The first one of them is the value of the incident angle equals the value of the reflected angle. The second one, incident ray, reflected ray, and the normal are all in the same point on the reflecting surface, and these are the two laws of reflection. If the light ray falls perpendicular on the reflecting surface, it reflects on itself, and in this case the incident angle will be equal to the reflected angle will be equal 0. Here is the light refraction, and this is very important. Light refraction is the changing in the direction of the light ray due to transferring it from one transparent medium to another, different in optical density and different in velocity. Here is air, here is glass, here is air. Light ray travels through the air, then transferring to the glass, it will be refracted. Refraction is meaning changing the direction of the light ray. This ray is supposed to travel in the same straight line, its way, but breaking this light ray is meaning refraction of this light ray, changing its direction when it travels from the air to the glass, and then from glass to the air. If it travels from a low optical density medium to a higher optical density medium, I mean from air to the glass, in this case the incident ray will be bigger than the refracted ray. First, this is the incident angle, the refracted angle, and this will be the emergent angle. If it is traveling from air to the glass, low optical density medium, higher optical density medium, the incident angle will be more than the refracted angle. If it is traveling from the high optical density medium to lower optical density medium, or from the glass to the air, it will the incident angle will be smaller than the refracted angle. Then here what I explained now, if the light ray falls perpendicular from one medium to another, it will pass without refraction, and this is the only way for traveling the ray without refraction. If you want to get the absolute refractive index of the medium, it equals the speed of the light in air over the speed of the light in the medium. Speed of light in air over speed of light in the medium will give you the value of which is called the absolute refractive index. The value of the absolute refractive index is always greater than 1. Greater than 1 is meaning what? Is meaning speed of light in the air is greater than the speed of light in any other transparent medium. Okay? We have some phenomena and some applications on the light reflection and light refraction. If you are putting a pen in the glass, this glass is containing water, you will see that the pen appears broken due to the light refraction. Here, if anything in the water, this is a basin which is containing water, there is a coin or a body is in the water. If you look at it from the air, you will see it higher than its real position. Higher than its real position. Why? Due to the refraction of light, and the eye, you will see the object at the extension of the refracted ray. There is a phenomena which is called mirage. Mirage phenomena is the natural phenomena, takes place in the desert, especially in the summertime, where objects on the side of the roads appears to be inverted on wet area, appearance of the water, wet area, and everything in the two sides of the road appears inverted. due to the refraction of light. I wish that you understand everything, and I hope that you will pass the exam with a very good and high marks. Just take care about the questions, read it carefully, correctly, with 2 ways, and then answer it. Thank you.